So it's like you suffer through the software. Okay, piecewise function. All right, so a piecewise function is breaking your graph into pieces, okay? And do you guys know what I mean about a domain statement? We'll get there. You guys know what the domain statement is. Yep. What? Yes. Oh, that should be a straight brag. And you guys are like, that makes no sense to me. The most important thing I want you to take away from this is we're doing domain statements. And what do domain statements deal with? They deal with the X values, right?
The f of x is like the same as y, right?
Okay, so in this, when it's in an equation, it functions the same as the y. But when I say f of x, that just means the function.
What does the function of x do?
The function of x, so every x value has a unique y value.
Okay.
I think I taught you this in grade 10,
Probably.
but nobody listens. Nobody listens to me. So all I'm asking you is to tell me which side of the graph belongs to the original function and which side of the graph is the absolute values of the function. I love it. There's a groan from the in-class crowd. Okay, we gotta go through this for this to make a little bit more sense. Everybody's gonna be okay. Says the math teacher. Okay. Okay. All right, example 1, we're gonna graph this. So today's lesson is all about graphing. I love it. Determine the x and y intercepts, sketch the graph, state the domain and range, state it as a piecewise function. Huh. Okay. What I want you guys to do first is you're gonna need 2 colors. Everybody got 2 colors? Okay. All right. Well, there is a abundance of things on my desk that you can borrow. Or a dash line and a straight line. Good to know. All right. Get creative. Use a dash line, whatever. Okay, so this is how we're going to graph them. I want you to graph this graph first. Ooh, that's supposed to be a 3. Okay, so notice all I did was take the that is a 3. I just take the absolute value brackets away, and I want you to graph that straight line. Okay. You don't know how to graph a straight line? What did I teach you in grade 10? No, I want you to graph this function. Oh my goodness, I don't remember. Totally. Okay, so let's identify some things. This is my y-intercept. I don't know where you're talking. Okay, so slope, remember, is the change in y over the change in x, or rise over run. Right, so the y-intercept would be -3. So hold on a second before you guys get crazy. I want to make a statement again. FYI, table of values will never lead you wrong. Okay, so if all else fails and you can't graph it the way I'm about to show you, because you guys all should know how to graph a linear equation, but it's been a long time. Remember that doing a table of values will never lead you wrong, and you can always graph using a table of values. I'm not going to do that. What do I need? 1, 2, 3, 4, 5. So that's -5. 1, 2, 3, 4, 5. You guys putting your increments on here? 1, 2. Yes. Of course you are. Okay, we good? Alright, so I'm gonna graph my lines. I'm gonna make this one, oh, green is pretty terrible, never mind. I'm gonna make this one red on my graph. Okay, so I'm gonna graph my y-intercept first, so it's at -3. So I'm putting a dot there. And then my slope tells me that I'm gonna go 2 up, because it's a +2, and 1 to the right. So 2 up, 1 to the right. And then from this point, I'm gonna go 2 up, 1 to the right. 2 up, 1 to the right, 2 up, 1 to the right. I can go also 2 down and 1 to the left. Because that would be a -2 divided by a -1. What does that give me? It still gives me that +2. No, it is. I started from my y-intercept and I went down to left. Down to left. And what do you notice about this? It's a straight line. Okay, so let's connect some dots. What? A linear. Linear. What does linear mean? I'm yelling at Danica, everybody, while I look for a ruler. How do we know it's not a parabola? What do parabolas have to have? They have to have that squared in there. Actually. You guys have done straight lines last year. Yes, I'm sure. I'm going to get a ruler.
Wait, it was actually Sarah's, the vertex and standard form for
Okay, too many words.
vertex form is for one, like, parameter.
Yes.
So it was 750.
Because there is no vertex, there's no turning point, there's no anything in this, right?
Stay away, I don't want your math.
Okay, have my ruler. I
Is that
had a
okay if
little
just
ruler.
freehand it 'cause I don't have my ruler?
Absolutely. Okay. So I graph my line. I'm gonna do quickly a table of values. You guys don't have to copy this down if you don't want to. You can just live the dream. So at 1.
Oh. I see. 1, 2. Is it just gonna like flip up wherever it's negative? Well, it'll just make the lines that I said.
Yeah.
+2.
Okay. All right. You guys agree with me?
Yes.
Okay. Those are my table of values that match that table. Okay. All right. I'm emotionally ready for this. Can you guys tell me where, well, we identified the y-intercept, right? It's at -3. Where's the x-intercept?
Like 1.5.
How did you get that?
Because if you're going up 2 every time, then like.
Okay. Did you calculate it, or are you reasoning it, or did you look at it?
I don't know, I just like.
Reasoning.
Okay, I'm gonna calculate it.
Okay.
So to find the x-intercept, what's y equal to? 0. So that means the f of x gets replaced with, not f of 0, because the x is not 0, it's the y that's 0. So the whole thing gets replaced with 0. Oh. No, that's 1.5. So we know that this graph crosses ish. That's a little less than 1.5. This is why I never look at a graph. This is why I never trust a graph, because I'm a bad drawer and that's not exactly 1.5. But we know our x-intercept is 1.5 because I've calculated it. And my drawing is just terrible. Okay, so we've done that and I'm calling this the original function. Because it has no absolute value brackets around it. Okay, all right, we're good, right? Everybody good? Okay, So now we're gonna start applying our absolute value stuff.
It's a parallel line.
Nope, nope.
Is it gonna be wrong?
What do we know? So now what we know in the absolute value, so if we do the absolute value graph, our table of values is the same, so -2, -1, 0, 1, 2, but this is the absolute value of 7, the absolute value of 5, the absolute value of -3, the absolute value of -1, and the absolute value of 1. So really, what's the absolute value of 7? -7, sorry. 7. What's the absolute value of 5? 5, 3, 1, and 1. You guys would agree with me?
Probably.
Okay, yeah, so let's graph those points now. So -2 is now +7. Ooh, sorry, off the graph there. -1 is -5. So notice that my x values didn't change. It's only my y values that are changing.
Do we only ever change the y value?
Yes. Yeah.
So that x-intercept still stays at like
So 0, what's the absolute value of 0? 0. Okay. So what do we know about this part of the graph? It's all negative y values. So can this exist? Can negative y values exist in my absolute value graph? No. So this part of the graph can't exist. What happens to it?
this guy, you put your dot on two.
Oh, what did I do with my dot? I put it on 2.
Yeah.
I was like, why is that so funky?
I was looking at it. But
See, and this is why I'm not allowed to graph things. So what do you notice about that line?
do we stop there?
I'm stopping, Xander, because I've run out of points on my graph, but I'm indicating that it goes on forever by using arrows.
So it doesn't go forever right there though?
I don't know what you mean by right there.
Like the line just stop. Well, can it?
Well, can it be down here?
Oh no, it's an absolute value.
Right? So what we know about absolute values is they have to be positive, so it can't keep going. All we did was change these values from negative to positive. What did you notice? It's like we put a mirror on the graph, on the x-axis, and they just flipped up. Okay, so remember when you guys were learning parabolas and I said you can't have that sharp V? Because that isn't a parabola. A parabola is a smooth curve. This one is a sharp V. Okay. So, what do you guys notice is the point of the sharp V? This. Anything below my x-intercept, we cannot have negative y values. No negative y values. Okay, so we can't have any negative y values. So my graph can go all the way down to the x-intercept, and then it mirrors, it pops back up. So I find it helpful as I'm learning to do these things to graph the entire line and then flip it up. Okay? Does the green part exist?
No.
No. I use that, that's my helping part.
So how would we calculate a table of values where we like do the equation inside and then just take whatever the number is and make it absolute value?
Okay, sorry, go again?
Like, you know how you have an absolute value? Because we like did the tables by flipping the numbers you already had.
Yep.
But you just like do what we did and like,
Put it into this equation.
okay, because I guess it's a bracket, you're doing everything.
You do everything inside of it. Yep. So absolute values are brackets, right? So we're going to do everything inside of it. So some of us who are proficient at graphing straight lines can do it without this helping part. This does not exist. So you need to either erase it, scribble it out, make it a dashed line, but it does not exist. So you need to scribble it. scribble it, erase it, or dash line it.
Those are only on.
Dash lines don't exist.
Dash lines don't exist on the actual graph. Like if it's a dash line, it's not really there. Does this part exist? This red part up here?
Yeah.
Yes, because those were positive y values. So the only part I want you to get rid of is those underneath. We good? Okay, we're not done yet. Okay, so we did this and we did that. Okay. Part C. I really shouldn't have put a cartoon on there. I could have used this. Okay, let's talk about domain. Domain of your absolute value graph. So remember that this doesn't exist and we're only looking at, and these both parts are part of the absolute value graph. You need both parts of the V to make up the absolute value graph. Well, remember domain is x values. Can I have negative x values? Yes. Yes, you have a whole bunch of them over here. So what's my domain? Brilliant. And don't forget your round brackets on that. So let's talk about range.
Zero to
Mhm.
Would it be like zero and then up, like infinity?
Yep. And remember a square bracket around 0 because it does include the point of 0. Okay. I need some more space for my maybe I don't. Maybe I can squeeze it in. Okay, so we did the domain and range, and now we're going to do the piecewise function. No, did I spell piece wrong? Yeah. No? Okay, piecewise. So now we're going to look at the part that was the original graph. So we're going to make a domain statement about the f of x graph. So that's the non-absolute value one. On my graph, it's the red one. And we're just talking about the domain. So where does my red graph start? What? At 3 over 2. Okay? Because we're just looking at the original, right? So we're looking at the original. So you're telling me that that one starts at 1.5. Where does it go, Pablo? Positive infinity. Ah, x-intercepts are super important in this unit. So now let's talk about the absolute value function. Where does that one start? Where did we do our flip? So this is the black side of my graph. So where does it start? 1.5, same place, but I included it in the original. So I'm going to use 1.5, but I'm going to use round brackets. Oh, shit. Excuse my language. Sorry, that wasn't mumbling curse words because I did it wrong. And where does it go? What kind of infinity? Negative infinity. Okay, so this is why what? Okay, so the reason why I'm not Pablo asked why am I not including the 1.5. Can I fix my mistake first? Before I answer that question, because it's making me a little squirrely. Anybody see my mistake? It's backwards. That's a half mark deduction. Because we always put our lower limit on the left hand side. Okay, so now I feel better. I can answer the question. The reason why it's not included is you have to, it can only belong to one function. Okay? We always put it with the original. We always put the point with the original. But you can't have them owned by both of them. And the reason why is because the 0, we calculated in the original function, and then, I don't know, we always put it with the original. I don't have a really good explanation for that. So you can call me out if I deduct you a mark for that one. Okay, so that's all it is to your piecewise function. Sorry, Madison?
On the second one, we just do round brackets then?
Yes,
Okay.
because it doesn't include that point.
Okay.
Is that a terrible thing, the piecewise? Okay, people get upset, but it's really not that bad when you think about it, and this is why I said 2 colors are good, because then I'm always thinking like what's red, what's black, or what's blue, what's black, that sort of thing. Okay, that was good. Good job, team. Way easier. Yeah, so now we're getting into, this was grade 10. This was grade 10 with a little pepper of grade 11. Now this is all grade 11. Okay, everybody take a deep breath. We are going to graph our parabola.
Is it just like wherever it gives under?
How do we know it's a parabola? Yes, Pablo. How do we know it's a parabola? Because it has a squared. Okay. Which way is my graph opening? Down. Okay, so we all know that it's opening down. Where's my y-intercept? 8. Is this in standard form or vertex form? This is in standard form. No, that's the y-intercept. So in standard form, we can see the y-intercept. In vertex form, we cannot see the y-intercept. We can always calculate it though, right? Let's do our x-intercepts. So we're going to do our x-intercepts on this graph.
How can we not see the y-intercept on a vertex form though? Isn't it like the value of that n?
No, that's your y-coordinate of your vertex,
Oh, that's the vertex.
right? So it's something totally different than your y-intercept. Okay, so if I'm finding my x-intercept, I'm going to go 0, negative x squared plus 2x plus 8. No. Oh, okay, yeah, you totally can. Yeah, you totally can. Sorry, I didn't understand. I was moving my paper. Danique asked if I can move it to the left-hand side, and you totally can. And I want to do that because I want a positive x squared. Or I could have common factored of negative 1. Either way would work, but I think we're used to moving it. So what are the factors in negative 8 that add up to a negative 2? Okay, all right. Look at us. We solve for our x-intercepts. What else do we need when graphing a parabola? Yeah, chapter 3. It's like she wasn't even here. We need the vertex. Yeah, that's a key point to graphing any parabola. We need the vertex. So which way do you guys want to do it? Do you want to complete the square or do you want to do the secret formula?
Secret formula.
Oh,
Simple.
okay.
Can we complete the square?
Okay. I'll start, okay, so x-intercepts, we gotta find the vertex. So I'm gonna complete the square. I guess that's CTS, complete the square. So I've got y equals negative x squared plus 2x plus 8. What's step 1? Group the x's. Step 2, we're gonna common factor out whatever coefficients on the x squared. And this time it happens to be a negative 1. Leave myself some space. What do I do now? Side note. So I take my negative 2, divide it by 2, square the result. So I'm going to have negative 1 squared, which is 1. So I'm going to add 1 in the brackets. What do I do outside the brackets? Subtract 1.
And then times it by negative 1.
Times it by that coefficient out there. Okay, so y equals negative 1. I'm going to factor that, and that's going to be x minus 1 squared plus 9. So we went from standard form to vertex form.
So the plus 9 is the y of the.
Yes. So my vertex is at +1, +9. So when you get it in vertex form, it doesn't show you the y-intercept. Standard form does. This is good. This is a good reminder of chapter 3. Danica, who is texting you that is more important than absolute value? What are you checking then? Okay, so do we feel confident we can graph this parabola with the 2 x-intercepts and the vertex? Sure. Guys, we're gonna have to go up by 2's this time. How do you feel about the x's? Should we just go by 1's on the x's? You don't, guys, your graph, if you change your scale, is gonna look a little bit different than mine. But we can't do that? Okay, alright, we're all being the same. Team parabola. I'm just trying to find like a marker that will show up. Okay, I'm gonna graph my parabola. So I know that I'm gonna have x-intercepts at -2. Okay, I'm waiting. Wait, I'm waiting. I'm getting told I have to wait. Green doesn't show up. I don't know what you're doing. Trying my best here. Okay. 2, -2 for my x-intercept and +4. Okay. My vertex is at 1 and 9, so right here.
Can you graph it with just 3 points?
Absolutely.
Where was that one again?
What?
Or the one above it?
1 and 9. 1 and 9. Your vertex. Which way does my graph open? Hopefully down, because it needs to touch those.
But will is open down.
Wait, so, okay.
It opens to the left.
So please note that my graph isn't a sharp V. It's not an absolute value yet.
I'm
So
terrible
it
at
should
drawing.
be curved, right?
It should be curved. We're just graphing a parabola right now. So this is my f of x function. Why do you hate this? This is chapter 3. We haven't not even done anything.
Maybe make this absolute.
Okay, let's make this absolute. What can't exist in an absolute function? -y. So this can't, and this can't. What happens to those? What happens to them? They get reflected up, right? I'm standing here doing arm gestures in the air that you guys at home are just not getting the benefit of, and they're not getting it. So this arm essentially is gonna flip up.
You're just freehanding.
Yeah.
You don't have to do any calculating.
No.
Stop.
It's fine, it's not.
Guys, it's okay. Relax. If you really hate this, do a table of values and move your points up. So let's feel better about life. Shall we pick -3? Well, because I know a -3 on the original graph will be a -y value. Look at your graph, sweetie. Like, the arm at -3 is below the x-axis. I don't know what you're talking about. So if I use y equals, and I want to know what y is when x is -3. So -3 squared plus 2 times -3 plus 8. So y is equal to a -9 minus 6 plus 8. so y is gonna be -7. So my coordinate pair there is -3, -7. So -3, oh, that's about right. That's odd that I would actually graph it correctly. All I did was find a point on that graph.
Do the
But
other
does
side.
that have to be a negative points, like a?
You need, cause what would be the point of picking a positive point up here? That's not gonna change. You guys didn't like the freehand, you just told me you didn't like the freehand, so I'm finding a way to make it work for you. So -3, 7, where does it flip to? -3, +7. So now my freehand, you're making my freehand look bad. What do we know about parabolas? They're symmetrical, right? So if, that doesn't mean at +3 it's gonna be that. Pardon? A 3 and 7? Would that point be on our graph? Would this be a negative, like, it would be 5 and 7, cause it's the distance away from the parabola, it's the difference away from the vertex. Danica, look at your graph. At 3, are you positive or negative? Positive. So that point can't match. Remember that it's symmetrical around the vertex. And this vertex isn't at 0. How far away from the vertex are you here? You're 1, 2, 3 points away from the vertex. So you'd have to go 1, 2, oh, that's not right. Oh, I was over here. So this is 4 points away from the vertex, so you have to go 4 points away from the vertex this way. So at this point, it would be 5 and 7, so it would be there. You guys are really trashing my freehand.
Can we just freehand it, like we don't have to calculate?
No, but you guys were upset when I did that.
No, I'm not upset.
No, but now we're not upset anymore. Okay, so now my terrible free-handed fixed calculated graph. So if you are not comfortable with free-handing it, what I'm looking for when I look at these graphs is that this is reflected up. That's the most important thing to me.
Is that, and it will be a V, right? Will it be a V?
It won't be a V here, it will be a sharp V here, yes. So, okay, Danica, I need you to stop. You're so busy saying, I can't do this, that you're not even accepting the information into your brain. Okay,
Refer back to the
'Kay.
last question, just think about it as.
all right, we're gonna state the domain and range of the absolute value graph. Just the absolute value graph. So what's the domain of that graph? Brilliant. What's the range?
Would it be
Negative infinity, 0 to +.
yeah.
So my domain is all my possible x values, and they can be positive or negative. What do we know about absolute y values? They have to be positive. So therefore my range has to go from 0 to only positive infinity. They can't exist down here, you guys know that.
So, okay, so it's positive infinity because those weird ones go on forever?
Exactly.
Okay.
Okay, now we're gonna do our piecewise function. Okay, so I break my parabola down into 2 parts. The hump and the arms. Okay? So these, what would you think these are? How many arms do most people have?
3.
Hopefully 2, okay? And the hump is this part, okay? So what did we flip up? The hump or the arms? Okay, how many arms does a normal person have? Or not a normal person, but how many arms does a person usually have? 2. Okay, just, I wanna repeat that, okay?
You would both think there would be equal arms.
Okay, so we're gonna do our piecewise function now.
Could I just put PW?
Absolutely. Okay, so we're gonna talk about the f of x graph first. We're gonna talk about the original.
So like the negative.
Nope. What part of our absolute value graph? The hump. So the original graph is the hump.
Yes,
Everybody agree with me?
yes,
Okay, we kept the hump.
okay.
Oh, this is, okay. It's very technical, these terms, all right?
Sorry.
So on the original graph,
And it's the domain,
it's the domain of the hump.
so infinity.
So -2.
Oh my goodness. What? Honestly, I get it.
-2 to 4.
And then usually the absolute one.
Okay, all right. We ready? So let's just slide the back up to this graph. We're saying our hump goes from -2 to +4. And it's inclusive of those points, right? Because that's where the hump goes. Okay, how many arms do I have? So I need 2 of these statements. Okay? Just give me a second. I write too fast and then I'm not writing fast enough. It's hard. Okay. All right. So now let's talk about our left arm. Yes?
and then -2.
It's backwards, right?
Nope, that one's right.
Okay.
Because where does this arm start? -2. And where does it go to?
Well, technically,
Goes
that's-
to
So then,
negative infinity.
technically,
No, but we always put our lower limit on the left-hand side.
what I meant by backwards.
Yeah, okay.
technically it starts at -2 and turns into -2.
Yeah, we're not there yet though, Jacob. Okay, let's talk about the other arm.
4, infinity.
Yes.
Why is it negative infinity?
Because it goes.
Because remember, we're doing domain, so we're talking about x's. We're not talking about y's.
Okay, yeah.
Okay, so hold on, we're not done this. We need to say that the arms are happening at the same time. So in math, we say that when things happen at the same time, we call it in unison. It's just a new word, everybody. It's in unison. And unison in math means that it's happening on the same graph, it's happening at the same time. So we represent that with the letter U in between these. But in math, our U does not have a stick on it.
I have to write this.
Did you say this?
So sometimes your arms are the originals. So you'd need the 2 statements on the original. Yeah, you need the U between the arms.
So let's say your arms were staying and your like body was flipping, would you include the points in the arms?
Yes.
Okay.
Yep. Okay, so that was fun.